Good morning to all. Welcome to IRES online classes. I am Krishna Mohan, mathematics faculty here. So today I want to discuss about one of the important concepts in geometry, that is mass point theorem. So what is mass point theorem and how to use this mass point theorem related to geometry, and what is Seva's theorem and Minala's theorem? What about the applications of those two theorems in geometry? Here in mass point theorem, consider a uniform rod, and we have to put 15 kg weight at one of the ends and 10 kg weight on the other end. To balance this rod, we have to put the fulcrum nearer to 15 kg such that the ratio of these two distances is equal to reverse ratio of the weights, nothing but 2:3. Here the weights are in the ratio 3:2, then the distances from this point to the two ends of the rod are 2:3. If this is M1, this is D1, then M1 into D1 is equal to M2 into D2. So this is the importance of a physics related concept to geometry. So how to use this one? Here, if this is the total weight 15 kg plus 10 kg weight, total weight acts as this point at the balancing point, that is 25 kg acts at this balancing point. So I want to use this concept related to triangles. Consider a triangle ABC. This is a triangle ABC. Draw three concurrent lines from three vertices of a triangle AD, BE, CF. These are the three concurrent lines drawn from three vertices of a triangle. Let the concurrence, the point of concurrence is O. If BD is to DC is given as 3:2, and if BO is to OE is given as 4:1, BD is to DC is equal to 3:2. BO is to OE is equal to 4:1. Then find AF is to FB. Find AF is to FB. So if two ratios are given, how to find the remaining ratios? Using this mass point theorem. Here, consider this as a rod. Let this is the balancing point. If distances are in the ratio 3:2, then what about the weights? The weights are in the ratio 2:3. For example, if you put 2x kgs weight here, and if you have to put 3x kgs weight here, and the total weight acts as this point, this is the balancing point, 2x plus 3x, so totally 5x kgs weight acts as D, acts at this point D. And here I want to consider this as a rod. Let this is the balancing point. BO is to OE is equal to 4:1. The distances are in the ratio 4:1. Therefore, the weights are in the ratio 1:4. One part is equal to 2x. 4 parts is equal to 8x. So 8x kgs weight acts as this point. Using this, here consider this is a rod, let this is the balancing point, the total weight 8x and this is 3x, therefore at A we have to put 5x to balance this. Here this is 5x, this is 3x and this is 5x, this is 2x, then we can find any ratio using this concept. For example, the weights are in the ratio of 3:5 here, the distances are in the ratio 3:5. So what is CE is to EA 5:3. Understood? So here also what is AF is to FB, at this point this is 5x, this is 2x, so total is 7x acts as this point. Here the weights are in the ratio 5:2. Here the weights are in the ratio 5:2, therefore the distances are in the ratio 2:5. This is 2 parts and this is 5 parts, therefore AF is to FB is equal to 2:5. Not only this, see carefully, this is 5x, this is 2x, this is 3x, this is 5x, this is 5x, 5x. Totally consider this is a rod, the total weight at this point is 10x. See carefully, 7 plus 3, 10x, 2 plus 8, 10x, 5 plus 5, 10x. Understood? So you can find what is AO is to OD. This is 5x, this is 5x, this is 1:1. AO is to OD. Then what is CO is to OF? This is 7x, this is 3x, therefore this is 3 parts, this is 7 parts. CO is to OF is equal to 7:3. Okay, so using this mass point theorem, we can find any two ratios. If any two ratios are given, we can find the third ratio using this concept. Not only this, here in geometry, one important concept is there, that is here, if this is a triangle, if three medians are drawn, this is median, this is median, this is one more median. Already you know what is a median. A line segment drawn from a vertex to the midpoint of opposite side is called median. And the three medians are concurrent. The point of concurrence is called a centroid, and the centroid divide the median in the ratio 2:1. So how to get this one? This is also same as this concept. Using this concept, we can prove prove the medians. AG is to GD is equal to 2:1. Here median means this is the midpoint, therefore ratio is 1:1. This is the midpoint, ratio is 1:1. This is also midpoint, ratio is 1:1. The weights are also in the same ratio. If this is x, this is also x kgs, this is also x kgs. And here 2x kgs weights acts at this point. Then here this is x, this is 2x. The ratio is 1:2. So AG is to GD is equal to 1:2. Centroid divide the median in the ratio 2:1. Sorry please. This is 2 parts, this is 1 part. Here if this is x, this is 2x, therefore the ratio is 2:1. Centroid divide the median in the ratio 2:1. Okay. Next. What about the Sevas theorem and Menela's theorem? Sevas theorem. Here, if this is a triangle ABC, three concurrent lines drawn from three vertices of a triangle. These are the three concurrent lines: AD, BE, CF. Then, according to Sevas theorem, BD by DC into CE by EA into AF by FB is always equal to 1. See carefully, this is a triangle ABC. AD, BE, CF are three concurrent lines. The point of concurrence is O. Then BD by DC into CE by EA into AF by FB is always equal to 1. So this is the important concept. I want to use the previous example for this also. If the ratio is 3:2, if this is 4:1, then what we get here? This is 2x kgs weight, this is 3x kgs weight, 1:4 ratio, therefore this is 8x kgs weight, this is 5x kgs weight. Here the ratio, the sides ratio 5:3, so this is 3 parts, this is 5 parts, and this is 5, this is 2, therefore this is 2 parts, this is 5 parts. See carefully, BD is to DC 3/2 into CE by EA 5/3 into AF by FB 2/5. What we get here? 5 cancel, 2 cancel, 3 cancel, which is equal to 1. So if any two ratios are given, BD by DC, CE by EA given, we can find AF by FB. I want to give a simple example based on the Seva's theorem. Based on the Seva's theorem. Here the example is, in triangle ABC, AD, BE, CFR, AD, BE, CFR, three concurrent lines intersect at O, and BD is to DC is equal to 5:3, CE is to EA is equal to 6:7. Then find AF is to FB is equal to how much? The options are 10:7, second option 7:10, third option 3:2, fourth option 5:3. Once again listen the question. This is a triangle ABC. Three concurrent lines, three lines drawn which are concurrent at O. BD by DC, CE by EA given, what is AF by FB. This is based on Seva's theorem. Very simple question. Here BD by DC into CE by EA into AF by FB is equal to 1. So what is BD by DC? This is 5/3 into CE by EA 6/7 into AF by FB is equal to 1. 3 1s, 3 2s cancel. So therefore AF by FB is equal to 7/10. So this is in the ratio 7:10. If this is 5:3, if this is 6:7, we can find AF by FB as 7/10, 7:10. This is called Seva's theorem. Okay. Next, I want to discuss about one more important theorem, that is called Menela's theorem. So what is Menela's theorem? What is Menela's theorem? So here, if this is a triangle A, B, C, a line drawn which cuts AB at F, AC at E, and extended BC at D. Here F is a point on AB, E is a point on AC, and D is a point on extended line BC. Then the same concept, BD by DC into CE by EA into AF by FB is equal to 1. BD by DC, CE by EA, AF by FB is equal to 1. So how to get this one? Here also we have to use the mass point theorem for this concept. For example, if this BD is totally 7 units, let this is 4 units and this is some 3 units. BD 7 parts, DC 3 parts. Okay, and let this be 2 parts and this is some 5 parts. Then what is AF by FB? What is AF by FB? So here BD by DC nothing but 7 by BD 7 parts, DC 3 parts into CE by EA 2 by 5 into AF by FB is equal to 1. Here what is AF by FB? AF by FB is equal to, this is nothing but 15 by 14, nothing but 15 parts is to 14. AF is to FB is equal to 15 is to 14. Okay, so how to use the mass point concept here also? Let this is the balancing point. Let this is the balancing point. BD, this is a 4:3. Let this is 3x units and this is some 4x units at this point. Okay, and this is totally 7x parts access this point 7x. You can take x value anyway, x as any value. So it is a multiple of 5 and 7. 5 and 7. Okay. So what is AF is to FB? 5 parts is equal to 7x. I want to consider this as 35 kgs. X as 5, so this becomes 15 kgs. Here x as 20 kgs. X is 5, 5 fours 20 kgs. 5 parts is equal to 35 kgs, so 2 parts is equal to how much? 5 sevens 35, 2 sevens 14 kgs here, 14 kgs. Then what is AF by FB? This is 14 kgs, this is 15 kgs, so ratio is 15 is to 14. So we can get the answer as 15 is to 14. So this is Menela's theorem. If any two ratios given, a single line and any two ratios given, we can find the third ratio. Okay, so I want to give one more example. This is an example given. This is a line drawn here like this, A, B, C, extended which meets at D, this is E, this is F. If this is seven parts, this is 2 parts, this is some 3 parts, this is some 5 parts, then what is AF by FB? BD 9 parts by DC 2 parts into CE 3 parts by EA 5 parts into AF by FB is equal to 1. So then what is AF by FB? AF by FB is equal to here 27, this is 10, 10 by 27. This is 10 parts is to 27 parts. So this is the importance of Menela's theorem. So I have discussed about what is mass point concept and what is Seva's theorem and what is Menela's theorem. Okay, using these concepts we can solve some more questions also. I want to discuss one more question related to this these concepts. Okay, yeah. Before going to solve this question, I want to give one important concept in triangles. This is a triangle ABC. Draw a line here from vertex A, AD, D is a point on BC, AD is joined. Here, if distance is this distance is BD 3 parts, DC 5 parts. So BD is to DC is equal to 3 is to 5. If these are in the ratio, BD is to DC are in the ratio 3 is to 5, then what about the areas ratio? Then what about a triangle ABD is to area of triangle ADC? Here if bases are different but height is same for both the triangles. If height is same for both the triangles, okay, bases are different, so areas are in the ratio of their bases. So if bases are in the ratio 3 is to 5, heights are same, therefore areas are also in the ratio 3 is to 5. So I want to use this concept to solve this problem. See the problem carefully. See the problem carefully. So I want to solve this problem. This is a triangle ABC. BE, CF are drawn. They intersect at O. Area of this part is 5 square units. This is 10 square units. This is 8 square units. Then what about the area of this part? Okay. So to find the area of this part, I want to use the mass point concept and also this concept. Listen carefully. I want to join AO. Let this is X, let this is Y. Consider this as a triangle. Here the areas are in the ratio 5 is to 10. Therefore, the bases are also in the ratio 5 is to 10, nothing but 1 is to 2. So FO is to OC is equal to 1 is to 2. This is one part, this is two parts. Similarly, consider this BEC triangle. Here, consider this as base. For these two triangles, height is same. The bases are in the ratio 10 parts, 8 parts. So, sides are in the ratio 5 parts is to 4. That is, BO is to OE is equal to 5 is to 4. Okay, so I want to use this concept to solve this question. So this is 5 parts, this is 9 parts, this is here a multiple of the total 9. I want to consider the total weight is equal to 27 kgs. Total weight is equal to 27 kg at O. 27. So 27 is divisible by 3 and also 9. Here, if this is 27 kg, the distances are in the ratio 1:2. Total 3 parts is equal to 27. Each part is equal to 9. So 9 kg weight acts as this point, and 2 that is 18 kg weight acts as this point. Similarly, see carefully, this is 27, totally 9 parts is equal to 27. So each part is equal to 3. 4 parts, nothing but 4 3s. 12 kg acts as this point, and 5 3s 15 kg acts as this point. 15 plus 12 is equal to 27. Okay, if this is 9 kg, this is 15 kg, already you know 9 plus 6 kg is equal to 15, and 6 plus 12 totally 18 kg. So this is totally balanced. Then I want to use the same concept here. See, this is 6 kg, this is 12 kg. See carefully, 6 12. So the distances are in the ratio here 1 part, and this is 2 parts. 2 parts, 1 part. 6 12 to 1. Then consider the total triangle. Consider this as base. Okay, this is one triangle. ACF is one triangle, and FCB is one triangle. The bases are in the ratio 2:1, therefore areas also in the same ratio. So therefore, see carefully, area of ACF triangle by FCB triangle FCB is equal to here 2 by 1, nothing but 2 by 1. Bases ratio same as the areas ratio, having same height. So what is the area of ACF? ACF area x plus y plus 8. X plus y plus 8 by what is the area of FCB? 5 plus 10, 15 is equal to 2 by 1, 2. Cross multiply. What is x plus y? X plus y is equal to 30 minus 8, which is equal to 22 kgs. Sorry, x plus y 22 square units. Sorry, please, square units. So the answer is 22 square units. This total area is 22 square units. So these are all the applications of the mass point theorem. Okay, so I have discussed 3 important concepts here. One is what is mass point theorem. Second one is Seva's theorem. Third one is Menela's theorem. Okay, based on that, even medians are also in the ratio 2:1 can be proved using mass point concept. Okay, so I think you have understood all these things. Thank you very much.